Thank you so much, Mia. Really appreciate the opportunity, and we're very excited to be friends of Women in AI Ethics. I've been following you and your work for a long time. Thank you for everything that you do, and I appreciate it. Appreciate the opportunity. So I'm going to share my screen so we can get started. Just give me one sec. And I'm going to just let me know if you still see it when I do that. Do you still see it? Yes. Okay, great.
Yeah.
Okay. So let me do that. See you. Okay. Well, thanks so much for joining us, everyone. My name is Anusha Satorama, and I'm the VP of Marketing at Fiddler AI. We're a responsible AI startup, and I'll tell you a little bit more about what and how we do. And I'm joined by my colleague, Mary Regan, who will walk us through a demo of Fiddler solution. Mary, do you want to do a quick introduction to yourself?
Yeah, hi everybody. I'm so honored to be here and really excited to sort of share what we are building at Fiddler. And I just want to say that last panel, it's just incredible to see the grassroots work that's being done. And I feel like we see ourselves as a partner to that, but I'm so inspired by all the talks today.
So true. I was noting down a point that Brandy was saying earlier about, the need for more regulation for tech and AI, especially AI, and that is something that we advocate for strongly as well. We've seen some of this being recently released with the EU guidelines, and we're hoping that this will come into existence soon. But in the meanwhile, we hope that companies will find incentives to build a foundation of responsible AI, and that is what we try to help with at Fiddler. Our mission is to build trust in AI so teams can use it confidently. So just quickly, I'm sure this crowd is probably really aware of a lot of these instances and examples we've seen on why AI models can cause harm and impact people's lives negatively. These are just a few of these examples. Models invariably lack transparency. They are not perfect. And when in production and encountering live data, performance can fluctuate. Bias, whether it's direct or indirect, is built into models and shows up when they're live and in production and dealing with customers. And this can also cause companies to end up paying hefty fines for being out of compliance with regulations. So the dark truth about AI is that models are invariably opaque. That is, that there is a lack of visibility, transparency, accountability. And no matter where in the business you work, whether it's the line of business, customer support, IT, data scientists, models play a role, and you will have questions about why and how these models are making predictions, if they're fair decisions, how to respond to customer complaints, and the basic question of trust. And on the point of customer support, what happened in that previous Apple Card example that I was talking about on the previous slide was that their customer success team ended up telling customers that it was the algorithm and we can't do anything about it. And that's just unacceptable, right? Like, we have to hold these algorithms accountable. And that's one of the main reasons why Fiddler was started as well, to build this trust into AI with a foundation of explainability. We've talked to multiple people over these last couple of years of us being in existence, and they express a lot of these problems. And so, thinking of this primarily from the data scientist and data science leader lens, there are things like, it takes too long to validate my models. I don't have a way to check for performance fluctuations like drift. And sometimes these drifts can end up being expensive and so on. So I think these are kind of like related incentives to start building this culture of responsible AI right away, but in a way that we can incentivize some of these people to think about it outside of like a regulation angle, for example. So how we look at Fiddler right now, we have application performance monitoring, or APM, specifically for product teams and DevOps teams. But this is sorely lacking for AI and ML teams. We need a way to know what's happening inside of those models, why is it happening, and how to resolve and move forward. It's this concept of visibility, explainability, monitoring, analytics, all kind of packaged into this one MPM solution. And so a little bit about Fiddler, we have been the first to market with an MPM solution like this. And our core value proposition is that we are powered through and through by explainability, which again brings that much needed trust, transparency, and accountability. And you'll see some of this as Mary walks through a demo as well. So just to kind of give you an idea of how this operates. So if you consider your models as those that are live in production and those that are offline and not yet in production, maybe still in the validation stage, we provide same levels of visibility into both and the ability to compare these two sets of models constantly to ensure that the best performing model is the one that's live. And the key to effective models is to ensure this continuous observation, monitoring, explanations. It can't be a one and done approach. So this cycle, this constant feedback loop kind of just goes on and on to ensure that you always have the best performing model out there in production. Um, so a quick idea of the kinds of industries we're working with. We've worked with multiple teams across various industries like banking, e-commerce, ad tech, gaming, recruiting, and so on to help with these very issues that I've talked about so far. With banks, for example, the other incentive outside of just thinking about it from a responsible AI perspective, which actually makes a big difference in banks because they're regulated, is to also help them unlock some of this revenue with explainability. Because of the regulated nature of that industry, they're unable to push some of these models out into production because they don't have the transparency that they need. But with adding things like this in, now they can actually move it forward. Teams use it differently. This is just an example of how this works inside of a bank, for example. So the data science team can use it to get real-time visibility into things like potential bias. They also use it for monitoring and troubleshooting. For one customer, what we heard was that we really helped speed up the process of finding some of these ML issues to make it 95% faster. So something that would take 3 to 6 weeks in the past, you can do it much quicker, maybe in less than 24 hours now. And then this is just a quick like, hey, we've been recognized by the industry type of slide. We host conferences as well. In the fall, we host our own Explainable AI conference too. And I would love to sort of have this community join us there. We have a lot of partnerships. We've been recognized by the World Economic Forum and Gartner. I now want to go like into the details of the demo. So it'll be great if Mary can walk you through a demo of everything that we've talked about so you can actually see this tool in action. Thank you so much for listening, and we do appreciate your time. Mary, I'm going to hand it over to you. Let me just stop sharing my screen.
That sounds great. And of course, like if anyone has any questions, at any point, you please like raise your hand. We're happy to help. And I think you can find us both offline. So maybe I just want to add, if there are things that you're not seeing that you wish you could see, please get in contact with us also, because we want to make our product better and we want to listen to the needs of many different aspects in our community. So this is, to get started, just like Anusha's saying, we really care about, bias, fairness, transparency, and responsibility with machine learning. And so our product really allows you to do this in a couple of different ways. So here I'm starting on this page. I'm going to move this over so I can see it a little bit better for myself. So here, I've uploaded into Fiddler a customer churn model. So this is looking at banking customer churn. So that's the likelihood of whether or not a customer is going to leave or stay with the bank. It's a pretty simple random forest model. And here I can look at all of the inputs, all of the features that we've put into the model, and I can see the feature impact. Can you guys see my mouse? Yeah, thanks, Anusha. Yeah, so we can see this is the global feature impact of each one. And here at the top, I'm going to go over to our monitoring tab. So, as you have a user has their model running up in production, data can drift over time, right? And this is an incredibly important area to pay attention to, because even if you've initially trained your model on, unbiased data, you've checked for everything, if your data is drifting over time, this can lead into a decreased performance in your model and really can lead to very disastrous outcomes and bias that then is happening in your pipeline. So as sort of a first stop, we have, data that's in production that now I'm feeding to Fiddler, and we can watch, these different metrics change over time for the model. So here we have decisions, and these are sort of basic business decisions. In this particular case, it's whether or not individuals are more at high risk or low risk for customer churn. But down here, I can track the accuracy of my model. So accuracy is not always the best metric. So we also include a variety of different metrics depending on what is most important for the use case. So we have recall, precision, F1 score, etc. But for this particular model, we can see for a long time, the accuracy is hovering around 0.8. And then starting a little bit after April 11th, we see this large drop in accuracy. So this, the model owners can have alerts for this that are set up in real time, that can let them know to come and investigate what's happening in their model. And we can go over and look at, say, the data drift that's happening for that same time period. So the light blue, I have the average model prediction value, and the dark blue is the prediction drift. So Fiddler in particular is calculating the Jensen-Shannon divergence. And so that's shown here. And again, this is for the model prediction. And so we can see right at that same time period that we saw that large dip in accuracy on the previous page, our model is really starting to drift in terms of its predictions. We also allow you to look into the drift analytics. So I can select a particular time bin. So say I am interested in this offending time bin. Our drift analytics are going to update for that particular place. And so I can look at this, in terms of each individual feature. So the first thing that's jumping out at me is that number of products is drifting quite a bit. So here we have feature drift for each of the features. We have the individual feature impact, and then we have this metric called prediction drift impact, which is really the feature drift times the feature impact. But I see number of products is really drifting a lot. So if I go back in time, say I come to this time bin, number of products really has a feature of drift of about 0.05. And afterward, I see it's, almost 10 times really that value at that point. So we can see this graphically represented as well. So this is, again, our prediction or the probability of churn that we're tracking here. But say I want to look at maybe one of the other features like has credit card. And again, the feature drift is this dark blue line. I really see sort of no change. But then when I come to number of products, I do see this sort of sharp spike. We also allow folks to check for data integrity issues. So we can look for missing value violations, type violations, and range violations. And for this particular model, it doesn't really seem to have an impact. There's no data integrity violations, but this could be a problem somewhere else. And again, we allow people to set up alerts for any of these things. So you can add an alert, and it can be performance, data drift, data integrity, and then it can either email you or you can have a PagerDuty services sort of set up in order to check on that. But going back to this particular use case, and again, this is really like, the human in the loop is so important. So of course we allow for, people to set up alerts and have something automated, but really you need, humans kind of coming in and digging in and understanding their own model. And we really believe in that. So here we have, data drift increasing a lot for number of products. Again, I'm going to select that particular time bin where that's happening. I can come down here to my drift analytics and look into number of products a little bit more. So here we can see really the feature distribution between the production data, which is in blue, and the training data. And I can see there's a pretty large discrepancy that's happening, or it's the drift that's being shown to me. This is definitely not the case when I'm looking at, say, some of the others where it's really matching up. So for this particular case, now I know, okay, so Fiddler's already told me that there's a big change that's happening in the data that's coming into my model. It's causing a decrease in the accuracy of my model, which could have a lot of implications depending on what this model is running for. And now I've identified already the main feature that's contributing to that. So we allow you to dig into this even further to understand it better. So we can click this export to analyze. It takes me over here to this analyze tab. So we have basically like a simple SQL query here that allows you to, so I can select, say, all of my data from that production data that's coming in this particular time window, right, where I saw the drift. So I'll run that. Here the data is coming up for that particular time window. And now I can we have a variety of insights that we can look into. So say so we have feature correlation and distribution and impact. So maybe I want to look at the feature impact distinction between my training set and this new production data that has come in. So here I'm seeing the light blue is the feature impact from my data set, and the dark blue is from this production data, or this slice that I've just run here. And I can see that there's this large change in number of products. It's become much more important in terms of the prediction value of the model. So we can also then, so let's say I want to look at the feature correlation. So, I know I have a bunch of different geographic regions, and I'm going to see how that's doing with number of products. And the first thing that's jumping out at me, all of the number of products for these other states look the same, but Hawaii has this very anomalous behavior. So I'm going to dig into that a little bit further. So I can say the geography is going to equal just to Hawaii. And I'll rerun my query. So let's add a new chart before I do that. I'm going to rerun my query and see what I get. And say I want to look at a slice evaluation. Actually, so let's look at the whole data set first before I do that. So we allow you to look at the slice evaluation. This is performance metrics for that slice evaluation. Sorry. Please hold. Right, so here's the performance metrics again. So this is for all the production data that's coming in, and I see that accuracy is around 0.65, right? That's what was shown to us on that first page. We do see that accuracy dip. And now I'm gonna look at it just for the region of Hawaii. So now we'll rerun that query, and I can see the accuracy just for the region of Hawaii has dropped incredibly low. So maybe this is something that I want to share with other people who are working on this model, and make sure that, each region is being treated similarly. So we can now even say I want to look at all the other states besides the state of Hawaii. So now I'm going to look at the slice query and the performance metrics for all other states, not including the state of Hawaii. And I can see the accuracy is actually just fine for the other states. So this really allows people, if you have drift that's happening in your data and you want to understand what's happening geographically and make sure that you're performing well across all of your slices, we really can help with that. Then we also have, let's see, I want to make sure I have enough time for everything. Then, so here we also have explainability capabilities, right? And so we're very big on transparency and making sure you understand what's going into your model. So like we've already seen, we can show, the global feature impact, say the global explanations of that's happening in your model. This can be really helpful for black box models, but we also allow users to dig into their data on a more granular level. So we can do this either with the training data set itself, or with the production data that we just were looking at. So let's say we do either one, I don't know. We can add filters if we're interested. So, say I want to look at the category of, geography, and I want to explore Hawaii even more. So I can really, explore to the granular level and really understand what's happening, with my model. So it's not this sort of black box thing that just is making predictions without any understanding on the model developer side. So here we can even dive into a point explanation. So here I'm selecting one data point that has a very high prediction or likelihood of churn. We allow, this is maybe for more the business user, it's like a less technical user can understand what's happening with their model. But for more technical users, we have this ability to sort of drill in even farther. So we can look at the feature attribution. So here we're looking at the feature attributions here, right, for this individual data point. And in fact, I can sort of play around with these values and rerun it and see how that would change the model prediction. So this is very helpful, I think, in particular for users who get denied loans and they want to understand reasons why, this can be helpful for that sort of use case. So here we have number of products, right? So right now this user has 2 number of products. If we switch that to 3 and I rerun the values, so their likelihood of churn right now is quite high. It's about 0.8, right? If I round, let's rerun this with the edited values, and the likelihood of churn has dropped quite a bit. So here we're using a couple of different algorithms in order to run these explanations. In this particular case, I'm using Fiddler SHAP, which is a proprietary algorithm that allows people to understand, how the model is making the decisions that it is. But we have a few others, including integrated gradients for more differentiable models. And now we're including capabilities that we call IG Flex, and that's for more hybrid type models. So right now we've been looking at a model that's just based on tabular data, but we can also now, we have the capability to explain models that are hybrid that include both, text or other types of sort of mixed modal data types. And lastly, and I want to leave a little bit of room for questions if there are anything, but we also have our bias and fairness capabilities. So this should be coming out soon. But we allow the checking for bias and fairness again, on your data set, also on your production data. But so we're looking at it through the lens of both data set fairness and model fairness. So here again, we can choose between these two. In this particular case, this is a project focusing on model census data. So it's using the US Census and the demographic information in order to see whether or not an individual is making above or below $50,000. Now, of course, so we have our protected attribute selection here, right? I think we all know that AI best practice is to not include, certain protected attributes when creating a model. So Fiddler allows people to include, different protected attributes as metadata in order to check for these biases. So here we can run, so let's say we select race and the favorable outcome above $50,000, right, from our training data. I'm going to run this, and the first thing that I want to look at is our data set fairness. So here we have a mutual information chart, and this is really checking for dependencies across your model features. So if you have a high value in one of these, it means that there's a large dependency between your protected attribute that you're interested in. So in this case, we're looking at race, and one of the features in your model. So if you see that, you might want to remove that feature from your model because it's acting as a proxy then for something like race. Of course, we allow people to check their label distribution across all the outcomes, right? This is very important to make sure that you're training your model on a balanced data set so that you're not obscuring any group when you're doing that. Then we also allow people to look at the model fairness. So this is just the model outcomes. And so in this particular case, we can see, that white individuals have a much higher positive outcome than any of the other subgroups. Okay, and so for the census data, it's hard because that's just a reflection of sort of where our country is at this moment. But you can imagine for other models, if you're getting an outcome like this, you definitely want to look into what is happening and change your model. We can look through true positive, true negative, false omission rates, false positive rates, false negative rates, and false discovery rates, and again, for each subgroup here. And finally, we have some very commonly used legal metrics. So we can calculate disparate impact, equal opportunity, demographic parity, and group benefit. So Fiddler, a very special thing that I think we're doing, there's been some wonderful recent work by Gebru and Buluimi that shows that just looking through one dimension for bias is often not enough. So we allow people to do sort of an intersectional look. So you can select as many protected attributes as you want, but for this example, let's look at both race and sex. And we can rerun it checking at this intersectional lens, looking for bias in that case. So say I go back to my model fairness, and now I'm seeing, white males are like far and ahead, doing much better than the rest of my subgroups. One last thing I'll mention, because we just have a couple of minutes, is that we do, sort of at a glance, this min-max ratio. There was a paper that we published recently on intersectional fairness and intersectional fairness metrics. And we use this min-max ratio, which is looking at the group that's doing the worst in comparison to the group that's doing the best for a lot of these well-known metrics. And so at a glance, you can kind of see how well your model is doing. And so I think we have about maybe a minute or so, but if anyone has any questions or wants me to go over something in more detail.
Thank you so much, Mary. Mia, that was all we had today.
Thank you so much again for making this happen. We'll see if folks have any questions. And generally, as we are getting to us, we've had a long day. So let's give folks a few minutes. And if they have any questions, are you available on Twitter after to connect with folks? Because we do encourage people to connect with you so that they can get their questions answered and so on.
Yeah.
So, right?
Yeah.
Yes, absolutely. Yeah. Yeah.
Okay. Again, Anusha, thank you for the introduction to Mary. So grateful that you could both join us. And again, thank you again for your support. People say there are no women in tech. We just need to go invite them. That's literally it. And you just proved it.
Yeah, well, thank you, Mia, for having us. We really appreciate the opportunity. Thanks, everyone, for listening. Feel free to reach out to either Mary or me on any of the social channels. Thank you.
Oh, there was one question. Maybe if you're on Twitter, maybe you connect there. It's about bias. So if you're able to answer it in like a minute, maybe we'll see.
Mary, do you want to?
Yeah, totally. So the question is, are you able to correct for bias when you find it? So, you know, I'm not sure, you know, what the person's background is, but, you know, each use case is very particular. So right now we show people when bias exists, but if, you know, and this is a kind of complicated answer, but each use case is very particular. So if we came out and told you without really understanding what your use case was, I think that we actually could do more harm than good. So we really want to empower our users, you know, to help and understand what, you know, their own use case is in order to really check for bias in the right way. So again, it would really depend on, their use case.
And I think it comes back to that human in the loop concept that we were talking about, to ensure that it's not something where you just say, hey, it's the algorithm, I can't do anything about it. So we believe in that pretty strongly, like Mary said. I know we're over time here, Mia, so